Alright folks, so for the second video, it's mainly going to be on section 7.3. Actually, I think it's all on 7.3. So again, I was here to kind of introduce it, but we didn't really talk too much about it for this section. So this point on, it's kind of stuff I was not there for. So I'm going to spend a little bit more time going in depth in these problems. Just so that you can kind of hear it from my perspective. So hopefully this will help out clear up some misunderstandings, because I heard that this was kind of one of the most missed sections of the quiz that y'all took. So 7.3 is kind of a lot like what we did in chapter 4. In chapter 4, we dealt with triangles being congruent. So we had all sides matching and all angles matching. And there was 5 different ways that we could show that we had two triangles were congruent. We had side, 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 angle, side, angle, angle, side, and HL, hypotenuse leg. Here with similar triangles, it's going to be actually a little bit easier because I'm going to have only 3 options. Okay, and if it's not one of these 3, they're not similar. Now I listed them in order of easiest to medium, kind of. Because with these, kind of thinking back about like those questions 5 through 9, or 6 through 9, excuse me, the angles have to be congruent, sides have to be proportional. They have to be in proportions, or their scale factors have to be the same, is another way of saying it. So angle similar is the easiest one to spot. Okay, because I've got 2 pairs of angles congruent, I don't need to worry about the sides. So if I look at 11 and 13 here, I know I've got 2 options. It's either going to be angle similar, or it's going to be nothing, because there is no sides. So if, like, for number 11, you give me side similar on the test, that's crazy talk. There's no sides given to you. Just 2 pairs of angles. Okay. So for this one, it's going to be angle similar. Remember, when you're writing out the statement, a lot like the congruent triangles, except now you got a similar symbol in the middle. X paired with E, they both had 1 congruent mark. Y and N both had no congruent marks, so they pair. And Z with W both had 2 congruent marks. They pair together. Okay. For 10, though, it's a little bit different. Okay. Because now I'm giving you some side links, so it's a little bit harder. Now you'll notice I have given you 2 pairs of sides. I did not give you the last pair of sides of that triangle. So that means there is no way that it's going to be side similar. Because I've only got 2 pairs of sides. So don't give me, again, something kind of crazy out there. Okay. So if I look, my side of 12 on the left hand, and that small triangle would have to pair with the whole thing of 20. So I would have to add the 2 pieces to get the whole thing of CM. My side of 21, which is CT, would have to pair up to get me to the whole thing of CP, which is 35. Okay? So there's 2 ways you can do this. You can either reduce the fractions, like I did down here, and make sure the scale factors are the same, or you can cross multiply. If the numbers are equal, you know their scale factors have to be the same. So the problem is, though, that only gives me 2 pairs of sides. The angle can come from a couple of different places. So I can either have a shared angle, so angle C is in both the small triangle and the big triangle. It's the same thing I did here to mark angle B for 13. Or I can have vertical angles, like I did here for number 12. Or, and you'll see in one of the proofs, if I have parallel lines, I can have either like alternate interior angles or corresponding angles. It's usually the 2 most common ones. Okay. So in this case, I had 2 pairs of sides, 1 pair of angles, the one shared in the middle, so it has to be side angle side. For number 12, it looks like at first it's going to be side angle side, But when I go to pair up 12 and 16, those are both the smallest, and 15 and 24, they're both the biggest. And cross multiply, I don't get the same scale factors. I don't get the same crosses. I get 288 and 240. So since those don't match, it's going to be not similar. Okay. Again, for this one, I've only got one pair of angles. So if you give me angle, angle, that's crazy talk. I've only got two pairs of sides given. So if you give me side, 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 that's crazy talk. Okay. So basically this one had two options, either side, angle, side, or nothing. And since those crosses didn't match, it was nothing. 13 kind of talked about briefly already. Already got a pair of angles marked. Shared angle is the last option. Okay. No sides given, so I know right off the bat, not side, angle, side, and not side, side, side. Only option I got to try is angle, angle. 14, no angles are given. Don't have any vertical angles, don't have any shared angles, don't have any parallel lines. So there's no way I'm getting an angle here. It's depressing, right? So that means my only option is side, side, side. Because the other two options require angles. So I can try side, side, side. If it doesn't work, then it's nothing. So when I try this one, 4 over 6 reduced down to 2 over 3, 6 over 9 reduced down to 2 over 3, and 7 over 10.5 reduced down to 2 over 3. If you divide out by 3.5 from top and bottom. You'll notice I did not cross multiply like I did for number 12 and 10 up here. The reason why is because I can't cross multiply 3 sets of fractions. Okay, so I had to go kind of old school and do the scale factors. It's just 2/3 here. For 15, I've got an angle already given to me. I've only got 2 pairs of sides here. So that means I'm doing side, angle, side, or it's nothing. Okay. So the 10 pairs with the 6, because those are both the largest numbers. 4.8 matches with the 8, because those are both the smallest. Okay. Cross multiply, they're equal. If you reduce the scale factor, you would have gotten 3 over 5, so they would have been equal as well. Okay, so you could have done that one 2 different ways. For 16 here, now we've got some options, because I've got 3 pairs of sides and I've also got an angle. Okay, so there's going to be more than one way to show that these are similar. One way is side, side, side. So I could have done 4 over 8, reduced down to 1/2, 5 over 10, reduced down to 1/2, and 6 over 12, reduced down to 1/2. All the same scale factors, so side, 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 similar. Or the other option, since the angles were congruent, we already know the scale factors are the same from side, side, side there. So 5 over 10 reduced down to 1/2, 6 over 12 reduced down to 1/2. We use the angle in between. So basically for side, angle, side, I wouldn't use that third pair of sides. That's fine. Okay. So ABC is going to be similar to EDC. The reason why, A is across from kind of that middle side length. E is across from that middle side length of 10. B is across from the largest side, 6. D is across from the largest side of 12. C is across from the smallest side of 4. C is also across from the smallest side of 8. Also, if the angles are congruent, you know they have to have the same placement of the letter. Alright, so I'm going to go ahead and do the 3 proofs here on this video, even though 19's on the next page, just because I keep the topics the same. So, you may have noticed on the answers here, pre-AP classes, you will have your proofs completely blank. I expect more out of you. For the CB college-bound regular classes, you're going to have some fill-in-the-blank, some word bank, and also a word bank for each of these. So kind of like what you've seen before for your proofs for both classes, because pre-AP's always had blank. CB, you're going to have some fill-in-the-blank. You also have a word bank. Alright, with these, you're kind of doing the same thing that you did above here for, let me see what number it was. For numbers 10 through 15, really including 16. Um, but you're kind of writing it out instead of just marking stuff. So like when I'm finding scale factors, I'm actually writing it in the proof here. I'm not just doing it off to the side. When I'm marking congruent angles, I'm mentioning it here in my proof as well. So if you look here, you'll notice I've got 2 pairs of sides mentioned. I do not have 3. So right off the bat, I know side, side, side is out the door. Goodbye. Okay. I have vertical angles, which gives me 1 pair of angles. If I look at this proof, I don't have any shared angles, don't have any other angles marked congruent, so I know angle is out the door. And clearly I would not have you prove something that's not true. So I know I'm proving side angle side here. Kind of helps with the last step. But I gotta verbalize kind of how we got to side angle side. So if you look, I have for the given, Mr. equals 3M, or 3IM. And LM equals 3MS. Okay. So with these, it's kind of a little bit different, but you're always doing the same step. You're trying to get the scale factors to be the same. So the only way to get that number by itself, that scale factor, is to divide both sides by IM. So I get Mr. over IM equals 3. LM, when I divide by MS, leaves 3 by itself. Okay, so I divided, so remember that's the division property. I also have called it division property of equality, or division POE. Any of those 3 works. Now, it's not just enough for me to find those scale factors of 3. I have to check to make sure they're equal. So instead of having MR over IM equals 3, I'm going to plug in LM over MS. Okay? Remember, when you are plugging something in, you are using the substitution property. It's like plugging in a different basketball player in a game. Okay, you're substituting a player in. Okay. And then finally, I mentioned the vertical angles. So SMI here and RML. Vertical angles there. Remember, if it was a shared angle, you would be using the reflexive property. If I had some parallel lines, it could be like corresponding angles or alternate interangles for a reason. For number 18, you'll notice there are no sides marked either in the diagram or in the given. So that means I know it has to be angle. Okay, so I'm looking for 2 pairs of angles when I'm looking through this. This one had a couple of different ways you could attack it here. One way, since I've got these lines are parallel, that means I've got this angle ORT and this angle OPN are corresponding angles. You notice I mentioned that here. If I wanted to make this really short, I could use the other pair of corresponding angles, OTR and ONP. 2 pairs of congruent angles, angle. Boom, done. I could have also used the angle here at O is congruent to the angle at O because it's shared in both the small triangle here and the bigger triangle. Okay, so that just would have made the proof a little bit longer because I would have had reflexive property, angle O congruent to angle O. And then you would have just needed one of these corresponding angle pairs. So there's a couple different ways you could have done that one. For number 19, again, you'll notice no side lengths. So it's got to be angle. Okay, so I've got these 2 right angles. So it's kind of obvious, right angles have to be the same, but we do need to state it in the proof. So since angle RAT and angle ROI are both right angles, they have to be the same. So they have to be congruent to each other, okay? So you don't have to write it specifically, all right angles are congruent. That's probably how you'll see it phrased on the SOL if they use this reason. But as long as you put something like right angles have to be the same, both angles are right angles, so they both have to be 90. Whatever. As long as you're saying because they're right, they have to be the same, you're good. That's all I want to see. So I've got one pair of angles. I know I'm trying to get to angle, so that means I got to find another pair. If you notice, this triangle rat, the small one, is inside that triangle ROI, so that means they are sharing that angle at R. When it is a shared angle, you're using the reflexive property. Okay.